Hello everyone, and welcome to the first video of the Quant section. In this video, we will first talk about our course structure and how the content of the quantitative section is organized and what methodology you need to follow in order to derive the maximum benefit from our lessons. After that, we will give a brief idea about the CAT exam and what to expect from the Quant section in the actual CAT paper. Finally, towards the end, we will start with some basic concepts of number systems. We will talk about the different types of numbers, how to convert a recurring decimal into a fraction directly with the help of a formula, and finally, a very short and a very brief introduction to factors, multiples, and prime numbers. So let's begin. Let's first talk about our course structure. As you may be aware, all our lessons are in the form of video lectures. Generally, these video lectures are between 15 minutes to half an hour in duration, and any particular chapter is divided into different number of videos depending upon the length and the complexity of that chapter. Now in the videos, we start by teaching some basic concepts, then we solve some examples on those concepts. The lectures are so organized that the difficulty level of the examples and the concepts increase as we solve more questions. After every topic, we provide a quiz which the student should attempt in order to consolidate the concepts which he or she has learned. And when we complete any chapter, the last video or the last two videos, whatever the case may be, contain some of the toughest questions asked in CAT from that chapter. Since CAT went online in 2009, we don't have question papers of CAT from that year. But we have the CAT papers from 1994 to 2008, and we have selected some of the toughest or trickiest questions asked in those years, and after finishing any chapter, in the last video or in the last two videos if the chapter is long, we will solve those questions. After that, we also provide you with a chapter-wise quiz. And this is how we will complete the whole syllabus of the Quant section of CAT. However, this is not where we are going to end our preparation. Now that our syllabus is complete, our focus will shift to solving more and more questions. So video lessons after that point will deal only with questions. We will learn some very important techniques that we will apply in solving the questions. Techniques like substitution, techniques of approximation, techniques to finding the right answer by working from the answer options, etc. In these videos, the level of questions that we will be doing will be slightly tougher than CAT. Let's say at a level 20 to 25% tougher than CAT. This is because when you are preparing for any competitive exam, it is always a good strategy to prepare at a level which is slightly higher than the actual exam. So in our course, first we will cover the syllabus, and while covering the syllabus we will get to a level which is sufficient for CAT, and after finishing our syllabus, we will focus on solving more questions, thus achieving a level which is slightly above the actual CAT paper. Now as far as study material is concerned, you do not need to buy anything else apart from our course material. We will provide you with all the theory as well as more than enough questions for practice. The only thing we need from your side is the willingness to work hard. We are providing you with everything else. Now let's talk about the actual CAT paper. In the CAT paper, you will get 60 questions in all, which you need to answer in 2 hours 20 minutes. The paper is divided into two sections, Quant and DI in one section, and verbal ability and logical reasoning in the other section. Both sections consist of 30 questions, and you get 70 minutes, that is 1 hour 10 minutes to answer a particular section. Note that it is not possible to jump from one section to another. Say your paper starts with the Quant DI section. Then for the first 70 minutes, you need to answer questions only from this section. If you finish this before 70 minutes, or say if you don't have any clue about any of the questions, you still cannot jump to the other section. Of course, within this section you can jump from one question to another. There is no restriction on that. You can reattempt a question, you can go back to a question, you can do stuffs like these. But you cannot jump from one section to another. After 70 minutes, you will be taken to the next section, and then you cannot go back to the previous section. So let's talk about the Quant and DI section. As already mentioned, it will have 30 questions which you need to answer in 70 minutes. So basically you get 2 minutes and 20 seconds for each question. Out of these 30 questions, typically you can expect 20 to 21 questions from Quant and the rest 9 to 10 questions from data interpretation. Quant chapters can be broadly classified into 4 categories: arithmetic, algebra, geometry and modern maths. And in the CAT paper, you can expect 6 to 7 questions from arithmetic, 4 to 5 questions from algebra, 4 to 5 from geometry, and 4 to 5 from modern maths. In the DI section, you can expect around 4 sets, either 3-3-2-2 questions, or 4-2-2-2 questions, or 3-3-3-2 questions, depending on the paper. But you can expect around 10 or 11 questions in DI, and generally 4 sets. Now, one question that students typically ask is how many questions to attempt in order to score 98 plus percentile or say 99 plus percentile. Well, there is no fixed answer to this question. The number of questions you need to attempt correctly depends on the difficulty level of the paper. But if you want to get a good percentile, one thing which you need to make sure is never miss out on any easy or moderate question. You have to make sure that you have answered every easy and moderate questions correctly. Typically you will get at least 15 questions, maybe even 20 questions, sometimes even more, which are easy or moderate. And you should make sure that you first attempt these questions. After that, you should move on to the more difficult questions in the remaining time. And never make it a matter of your ego to solve any particular question. If you cannot solve a question, move ahead. The strategy you should follow is read the first question quickly. If you think you can solve it in less than 2 minutes, you are 100% sure about it, then attempt that question. If you think you may be able to solve it, but you know it may take you more time, or if you are not 100% sure, then mark that question for review and move on to the next question. If, however, you don't have any idea about what the question is, simply move ahead. In the first attempt, do this for all the questions. In this way, in the first round, you will be able to solve at least 10 to 15 questions. Anything between 10 to 15 questions. Then go to the review section and start attempting all the questions that you marked for review. After doing that, in the remaining time, you should try to attempt the remaining questions. Questions which you felt you had no idea about. This is how you should go on about attempting the paper. Of course, in our course, we will be dealing with more strategies on how to attempt the paper. For now, this much is enough. Let's start with our first topic, which is number systems. The topics that I am going to teach here are very basic. I am sure most of you are already familiar with the concepts that we will deal in this video. My aim is to quickly revise these concepts so that from the next video onwards, we can start the actual preparation of CAT. So let's begin. Let's first learn about the different types of numbers. The first is natural numbers. Natural numbers are also called counting numbers. As is obvious from its name, counting numbers are used to represent things that we can count. Thus, the numbers 1, 2, 3, 4, 5 and so on are called natural numbers. Then we have whole numbers, which contain an additional number, that is, the number 0. The set of natural numbers plus the number 0 is called the set of whole numbers. Thus, the numbers 0, 1, 2, 3, 4, 5 and so on are called whole numbers. Then we move on to integers. The expanded set of numbers that we get by including negative numbers is called integers. Thus, integers are natural numbers plus their negatives plus the number 0. So the numbers, let's say -3, -2, -1, 0, 1, 2, 3 and so on are called integers. The integers extend on both the sides till minus and plus infinity. It's important to note that the number 0 is considered to be neither negative nor positive. Then we have fractions. A fraction represents a part of a whole, or more generally, any number of equal parts. Thus, when an object is divided into a number of equal parts, then each part is called a fraction. The top of a fraction is known as numerator and bottom of a fraction is known as denominator. The denominator of a fraction can never be 0, as division by 0 is not possible. It's not a valid mathematical operation. Fractions are of several types. Let's study some of them in more detail. The first one is proper fraction. Proper fractions are numbers which are smaller than 1. Therefore, in case of proper fraction, the numerator is smaller than the denominator. Some examples of proper fraction are 1 by 3, 1 by 2, 3 by 4, etc. Improper fractions are numbers which are larger than 1. Therefore, in case of improper fraction, the numerator is larger than the denominator. Examples of improper fractions include 5 by 2, 21 by 4, etc. Mixed fraction has a combination of a whole and a part. For example, 1 by 4, where 1 is the whole and 1 by 4 is the part, 2 by 3, 5 6 by 7, etc. Note that a mixed fraction can be written as an improper fraction and vice versa. Equivalent fractions are fractions that have the same value, even though they may look different. The fractions 1 by 2, 2 by 4 and 4 by 8 are equivalent fractions as they have the same value. Like fractions are fractions with the same denominator. For example, 5 by 23, 7 by 23, 10 by 23, 11 by 23, 14 by 23 are all like fractions as they have a common denominator of 23. Unlike fractions are fractions with different denominators. Now, an important type of questions that we get on fractions is comparing two or more fractions. Such questions can be asked in other aptitude exams. It's not generally asked in CAT, but it can be asked in other aptitude exams. We will learn 5 methods of comparing fractions. But as 2 of them involve percentage and approximation techniques, we will cover this after we finish the percentages chapter. Let's move on to rational numbers. Rational numbers are numbers of the form of p by q, where p and q are integers and q is not equal to 0. Remember, we said that division by 0 is not possible. So any number of the form p by q is a rational number if p and q are integers and q is not equal to 0. Some examples are 3 by 4, minus 5 by 6, 5, etc. Why 5? Well, because all integers can also be thought of as rational numbers with a denominator of 1. 5 can be written as 5 by 1, right? It can be proved that if a number when written in the decimal form either terminates or starts repeating, it can be written as a rational number in the form of p by q. Hence, rational numbers include integers, terminating decimals, and non-terminating recurring decimals. Let's now move on to irrational numbers. There are numbers that cannot be expressed in the form of p by q, and these numbers are called irrational because they are not rational. For example, root 2. It's not possible to write root 2 in p by q form, and hence root 2 is an irrational number. Now, root 2 is not an integer, right? Therefore, root 2 by 1 is not in the form of p by q, because p and q need to be integers. Root 2 is not an integer. Irrational numbers share the following properties. They cannot be expressed in the form of p by q. Hence, in their decimal form, they are both non-terminating and non-reoccurring, that is, non-repeating. Some examples of irrational numbers include root 2. Root 2 has a value of 1.414213563 and so on. It never terminates, it never repeats. Another example is root 3, which has a value of 1.7320508075 and so on. It neither terminates nor repeats. Another very important irrational number is pi. Pi has a value of 3.1415926535 and so on. Never ends, never repeats. Note that 22 by 7 is not the exact value of pi. 22 by 7 is an approximate value of pi. Sometimes for easy calculations, pi is written as 22 by 7. But 22 by 7 is a fraction, it's a rational number, whereas pi is not a rational number. 22 by 7 is only an approximate value of pi. We now list 3 properties which will be helpful to you in solving questions. Property number 1. The sum or difference of a rational number and an irrational number is always irrational. For example, 2 plus root 3 is irrational. The product or quotient of a non-zero rational number with an irrational number is irrational. For example, product of 2 and root 3 is 2 root 3, which again is irrational. If we subtract, add, multiply or divide two irrationals, the result may be either rational or irrational. What this means is that rational and irrational numbers do not mix. In case we get a situation where an irrational number has appeared while solving a question, it will remain till the end of the solution unless it is multiplied or divided by a multiple of the same irrational number or added to its additive inverse. Let's now move on to real numbers. When we combine rational numbers with irrational numbers, the set of numbers obtained is called the set of real numbers. Any number that represents an amount of something, let's say weight, height, volume, distance between 2 points, etc., will always be a real number. Real numbers are represented by all the points on the number line. Now in our syllabus, we will deal only with real numbers. However, even real numbers do not complete the set of numbers. Let's say we need to find the square root of -4. Then, such a number cannot be expressed in terms of real numbers. In the set of real numbers, square root of negative numbers is not possible. So we define complex numbers to find such values. Root of -4 can be written as 2i, where I is equal to under root of -1. We will not study complex numbers in any more detail as it is not in our syllabus. All the numbers that we have studied till now can be denoted with the help of the following chart. As can be seen, numbers can be classified into two types, real and complex. Complex numbers is not in our syllabus, so we have not studied it. Real numbers are classified as rational and irrational. Rational numbers are further classified as integers and fractions. Whole numbers are a subset of integers, and natural numbers are a subset of whole numbers. In terms of Venn diagram, numbers can be shown as follows. As can be seen, natural numbers are subset of whole numbers are subset of integers are subsets of rational numbers. Also, rational numbers and irrational numbers are disjoint sets, and together they constitute the set of real numbers. Let's now learn how to convert non-terminating recurring decimals into fractions. Now if the decimal has an integer part as well, separate the decimal part from it. For example, if we have a number like 2.6 bar, write it as 2 plus 0.6 bar. Then find the value of 0.6 bar in terms of fraction, and then we'll add it to 2. Now there can be two types of recurring decimals. The first one is pure recurring decimals, where the reoccurrence starts immediately after the decimal point. For example, 0.3 bar. 3 is repeating, right? And it has started repeating immediately after the decimal point. Another example is 0.51 bar. Here 51 is repeating, right? And again, the reoccurrence has started immediately after the decimal point. Another type of recurring decimal is impure recurring decimal, where the reoccurrence occurs after a certain number of digits in the decimal. Hence, a few digits after the decimals do not repeat. For example, 0.2123 bar. The bar is only on top of 23. Hence, 2 digits after the decimal do not repeat, that is 2 and 1 do not repeat, and after that the reoccurrence starts. Another example is 0.01421 bar. The bar is only on top of 21. Now we will deal with these two cases separately. Let's start with the first one, pure recurring decimals. I am only going to teach you the shortcut method or the direct formula of converting these decimals into fractions. I am not going to teach you the conventional method because that is not at all important and that's a waste of time. In aptitude exams, nobody is going to check the method that you are using to solve a question. The only thing required is the right answer. So I'm only going to teach you the direct formula. Let's start with converting pure recurring decimals into fractions. Okay, so let's start with pure recurring decimals. Let's say we need to convert 0.6 bar and 0.51 bar into fractions. Now, whenever we get such decimals, its equivalent fraction would be of the form of a by b, where a, or the numerator, consists of all the repeating digits written once. Thus, in our first example, that is in 0.6 bar, as only 6 was repeating, we write 6 in the numerator. In the second example, we have 0.51 bar. The bar is on top of 51. So 51 is repeating, right? Therefore, we write 51 in the numerator. Easy, right? Now finding the denominator, that is finding b, is equally easy. We just write 9s in the denominator. The number of 9s we write is equal to the number of repeating digits. In 0.6 bar, there was only one digit that was repeating. Only 6 was repeating, right? So in the denominator, we write only a single 9. That is, we just write 9 in the denominator. In the second example, we had two repeating digits. 5 and 1 were repeating. We had 0.51 bar. So 5, 1 were repeating. That is, two digits were repeating. So we write two 9s in the denominator, or we write 99 in the denominator. So in the first case, 0.6 bar is equal to 6 by 9 and 0.51 bar is equal to 51 by 99. Very easy, right? We just look at a decimal and we write its equivalent fractional value. Let's say 0.598 bar. In that case, the answer is 598 divided by 999. That's it. That's the answer. So to summarize, to convert such decimals, we use the formula fraction is equal to repeating digits written once upon same number of 9s as the number of repeating digits. Let's now learn how to convert impure recurring decimals into fractions. When we get an impure decimal, such as let's say 0.3457 bar, the bar is only on top of 7, or 0.3241 bar, the bar is again on top of only 41. Its equivalent fraction would be of the form a by b, where a, or the numerator, is the number which is formed by writing all the digits once minus the number formed by writing all the non-recurring part once. That is, the numerator is the difference of two numbers. And what are those two numbers? The first number is the number formed by writing all the digit once, and the second number is the number formed by writing all the non-recurring part once. In 0.3457 bar, the number formed by writing all the digits once is 3457, and the number written without repeating digits is 345. So the numerator is their difference, that is, the numerator is 3457 minus 345, which is equal to 3112. And in the second case, that is, in 0.3241 bar, the number formed by writing all the digits once is 3241, and the number written without repeating digits is 32. And then the numerator is the difference, that is 3241 minus 32, which is 3209. To find the denominator b, we write 9s followed by zeros. The number of 9s we write is equal to the number of recurring digits. The number of zeros is equal to the number of non-recurring digits. In 0.3457 bar, the number of repeating digits is only 1, as 7 is repeating. So we write 19. And the number of non-repeating digits is 3. 345 is non-repeating. So the number of zeros is 3. We write 9s followed by zeros. So we write 19 followed by 3 zeros. That is 9000 in the denominator. In the second example, the number of repeating digits is 2. 4 and 1 are repeating. The number of non-repeating digits is also 2, as 3 and 2 are non-repeating. So we write 9900 in the denominator. So the values of our two fractions are 3112 divided by 9000 and 3209 divided by 9900. To summarize, to convert impure decimals into fractions, we use the formula fraction is equal to number formed by writing all the digits once minus the number formed by writing all the non-recurring part once divided by 9x times 0y times, where x is equal to the number of recurring digits and y is equal to the number of non-recurring digits. Let's now also briefly discuss factors, multiples and prime numbers. These three topics, that is factors, multiples and prime numbers, are very important from the exam point of view. But in this video, we will only learn the basics of these concepts. We will revisit these three topics in a later video, where we will learn some pretty cool tricks related to them. But in this video, we will only focus on the fundamentals of factors, multiples and prime numbers. So let's start with factors. A factor of any number n is defined as a natural number which completely divides n without leaving any remainder. A factor is a part of a number, and two or more factors multiplied together give us the number. A number can have many factors obviously, but every number has at least two factors, the number 1 and that number itself. For example, the factors of 2 are 1 and 2. Only 1 and 2 divide 2, right? Remember, factors always need to be natural numbers. Factoring a number means taking the number apart to find its factors. Let's say we need to find the factors of 14. Well, as we know, 1 divides 14, so 1 is a factor of 14. Similarly, 2 is a factor of 14. 3, 4, 5 and 6 do not divide 14. 7 is a factor of 14. Then obviously the next factor cannot be between 7 and 14. So the next factor of 14 is 14 itself. So in general, to find the factors of a number n, we have to see which all numbers divide n. We need to check all the numbers from 2 to n by 2. And all the numbers between 2 and n by 2 which divide n are factors of n. In addition, 1 and n itself are also factors of n. Based on the number of factors a number has, natural numbers can be divided into either composite numbers or prime numbers. So what are prime numbers? The numbers other than 1, whose only factors are 1 and the number itself, are called prime numbers. That is, a prime number has only two factors. Some prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. Composite number, on the other hand, is any number that has more than two factors. For example, 9 is divisible by 1, 3 and 9 and so has three factors, hence 9 is a composite number. It is important to note that 0 and 1 are neither prime numbers nor composite numbers. The lowest prime number that we have is 2 and 2 is also the only even prime number. This is because any other even number has at least three factors, 1, 2 and that number itself. And the lowest odd prime number is obviously 3. Now, like I mentioned, this video is only an introduction to factors, multiples and prime numbers. So we are not studying them in more detail. We will study some more important properties of prime numbers in a later video. For the moment, let's move on to multiples. To get multiples of a number n, we multiply n by natural numbers 1, 2, 3, 4, 5 and so on. For example, multiples of 20 are 20, 40, 60, 80, 100, etc. The number of multiples of a given number is obviously infinite. And obviously, a number is a multiple of each of its factors. For example, 20 is a multiple of its factors 1, 2, 4, 5, 10 and 20. A number for which sum of all its factors is equal to twice the number is called a perfect number. For example, let's take 6. Its factors are 1, 2, 3 and 6. Their sum is equal to 1 plus 2 plus 3 plus 6, which is 12, which is twice the number. So 6 is a perfect number. Similarly, 28 is also a perfect number. Now let's move on to even and odd numbers. Integers which are divisible by 2 are called even numbers. Some examples are -6, -4, -2, 0, 2, 4, 6, 8, etc. And integers which are not divisible by 2 are called odd numbers. Examples are -5, -3, -1, 1, 3, 5, etc. Negative integers are also classified as odds or evens. So the concept of odd and even numbers is defined for the set of integers, not only for the set of natural numbers. This is an important property to note. And 0 is an even number. 2n is used to denote the set of even numbers, where n is an integer. 2n plus 1 is used to denote the set of odd numbers, where n is an integer again. Hence, 2n and 2n plus 1 taken together denote the entire set of integers. Let's learn prime factorization now. When a number is expressed as a product of its factors, we say that that number has been factorized. Thus, when we write 24 is equal to 2 into 12, we say that 24 has been factorized. By prime factorization, we mean factorizing numbers in such a way that all the factors are prime numbers. All composite numbers have the property that they can be written as a product of their prime factors. For example, 24 can be written as 2 into 2 into 2 into 3, that is 2 cube into 3, as 2 and 3 are prime numbers, and 24 has been written as a product of only prime numbers, we can say that 24 has been prime factorized. Now we are not doing any question on this topic at the moment. The reason is because in this video, we have only gone through the basics of factors, multiples and prime numbers. Most of the students preparing for CAT will already be familiar with these topics. We will revisit these concepts in more detail in a later video. For students who are not comfortable with these topics and need more help, we are giving some questions for practice. If anyone still needs more help and needs more videos and more tutorials on these topics, please contact me and I will provide you with all the help and support that you need. So let's meet in the next video where we will start with our preparation of CAT. So see you in the next video.